Some time ago, I did a video on the TopRC Retract controller model 2021. Since then, the controller has been updated. It's more compact, but the functions remain the same.
Extraordinary.
At first, this controller was intimidating for me, but after I tinkered with it a bit, it turns out to be pretty simple and straightforward. The input voltage range is 6 to 8.4 volts. And what I like to do with electric retracts is to use the maximum voltage allowed, in this case 8.4 volts. However, I don't like to use LiPos, especially when they're buried in the airplane. So what I opted for was a 4-cell lithium-ion battery rated at 14.8 volts. I chose this battery simply because I have it. You could just as well use a 3-cell. The whole idea is to use a voltage regulator and regulate the input voltage to as close to 8.4 volts as you can get it. In this case, I set the Castle voltage regulator at 8.5. The net voltage at the controller is 8.39. That's close enough. There are 3 inputs. The input voltage, which we just discussed. The brake input is the signal from the receiver on whatever channel you use and whatever control you use on the transmitter. And the retract input is whatever channel from the receiver that you choose for the landing gear and whatever control on the transmitter that you will use as well. Again, very simple, straightforward. There are 2 test functions on the controller, the brake test and the retract test. These are handy during setup, whether it's on the bench or at the flying site. Allows you to cycle the gear or test the brakes without having the radio connected. The retract test is just what it sounds like. You press the button, and if the gear is retracted, it'll extend, and if the gear is extended, it'll retract. This will also operate the gear doors, however you have those configured. Now, the brake test is a little different in that the controller is a proportional brake function. When you're hooked up to your radio, you can set the high endpoint or the on endpoint lower, and it goes into like an ABS kind of mode. You can set it from 100 down to 0 if your transmitter is capable of it. However, when you use the brake test on the controller, it is not proportional. It's 100% all in, so it's going to lock up the wheel, but you'll know that the brake is working. There's 3 outputs. There's the brake output, the retract output, and the servo output. The brake output, again, simple stuff. You got a left brake and a right brake. Pay attention to the polarity, plus and minus. They don't use a signal wire on it. It's only 2 wires going to the brakes. The retract output, pretty simple. There's 3 retracts and 3 connections. What I do is from left to right, 1, 2, 3. I use 1 and 3 for the mains and 2 for the nose wheel. You match the polarity and the gear will all operate in the same direction. Next, over the servo output, those are your gear doors. And again, you've got 1, 2, 3. The same sequence as I use for the retract output. 1 and 3 for the mains and 2 for the nose gear door. Again, simple, straightforward stuff. No tricks. There is a jumper plug, 6-volt and battery. If you're using a high voltage input, in my case 8.4 volts, you want to set the gear door voltage to whatever the servos can handle. So in my case, I'm using D-series high-techs, which are high voltage. So I've got mine jumper set at battery, whatever the input battery voltage is. However, if you're using a lesser rated servo, you want to set that jumper plug at 6 volts. Now on the configuration controls, you'll see some dip switches and some up and down buttons. Let's start with servo reverse. You got 1, 2, 3. The dip switches are on or off, A or B, whatever you choose to think. Again, 1 and 3 are the main doors. 2 is the nose wheel door. If the door is going the wrong way, flip the switch and correct it. Now, while I'm setting up the doors, I take the strut out of the Retract unit because the doors won't operate unless the retracts are plugged in. So remove the strut so that you don't have the wheel and the door conflicting. Now, retract mode, again, that's dip switch controlled, and I think of this as you got 2 modes. You got P47 mode and P51 mode. P47, when the gear is extended or down, the doors stay open. P51 mode, which is what I set up the L39, is when the gear is down, the doors go back up. And then to cycle the gear back up, the doors will open, gear goes up, doors close. Again, there's no big trick to it. The servo travel is endpoints increase or decrease to where the doors are operating properly. And that's about it. Take your time, be patient, and you'll have it all under control in no time.